As an introduction to Excel Solver, we're looking at a simple linear optimization problem. And in this case, we're looking at a factory that has one machine, and we have three different products that we can produce. The products generate different profit margins, but they also have different processing times, and we have defined customer demand. So the problem is, in this case, to optimize the production program so that we maximize the profit margin while also considering that our machine has a limited production capacity. We have three product types and the profit margins differ. Product A has a profit margin of $2 per unit, product B a profit margin of $4 per unit, and product C a profit margin of $3 per unit. We also have a sales forecast. So our sales department has developed a sales forecast for the upcoming period. And the logic here is that if we produce more than what the customers actually demand, we will have to scrap the products. So we don't want to produce more than what the sales department has forecasted in terms of customer demand. And the forecasted demand for product A would be 1,000 units. For product B, the forecasted demand is 50 units. And for product C, the forecasted demand is 400 units. The last thing we need to consider is that our machine has a limited production capacity, in this case 1,200 minutes, and the products have different processing times. Product A has a processing time of 3 minutes, product B a processing time of 4 minutes, and product C has a processing time of 2 minutes. And in this case, we also do not consider any changeover times or setup times, just for simplicity. So the processing times are the only times that are relevant in this case, and we need to make sure that we don't produce more than what the machine can actually produce. So our production program should consider that the machine has a limited production capacity. So we can model this problem mathematically, which should always be the first step. And after we modeled it mathematically, we can implement it in Excel and solve it with Excel Solver. Let's first focus on developing a mathematical model. And in this case, I will do it in Paint so that we can draw it here next to the problem description. I can see here I have a lot of information that is available. This would be the input data to my problem. So I know the profit margins. I know that there is only one machine. I know that there's a defined customer demand. There's a defined machine capacity, and there are various processing times that are defined for the different product types. So these would be the coefficients and parameters of a model. Our constraint values would be the machine capacity, and in the objective function itself we have coefficients here for defining the profit margins per product produced, and for the constraints we also have the market demand as constraint values. So let's try to model this mathematically. The first thing that I want to define is a decision variable. And in this case, I want to use three decision variables, x1, x2, and x3. These decision variables define how many products I want to produce of each product type. So x1 would be product A, x2 would be product B, and x3 would be product C. These are the relevant decision variables because this is what I can make decisions about. I can decide in my production program how many units of each product type I want to produce. Now, strictly speaking, these decision variables can only take integer values. So I'm just gonna add this here. Next, what I would like to do is to define the objective function and the objective. The objective in this case is to maximize profit margin. And the profit margin itself can be modeled with an objective function. In this case, the objective function would be P1 x1 plus P2 x2 plus p3 x3. P1, P2, and P3 are the profit margins of the product types A, B, and C. And I need to define that I want to maximize this. So now I define my objective and my objective function, and also the relevant decision variables, x1, x2, and x3. Next, I need to add all of the constraints that my solver needs to know in order to find an optimal solution. Now, the constraints are that I cannot exceed customer demand, and I cannot exceed machine capacity. So we have in total 4 constraints, and I will add them here to the mathematical model. So the way to do this is, if you want to define it correctly, to write here such that, and then we list the constraints here. So in total, we have 4 constraints. First constraint is that x1, being an integer, cannot be bigger than expected demand for product A. And likewise, x2, which is the amount of product B that we will produce, cannot be bigger than the expected demand for product B. And in the same way, x3 cannot be larger than D3, which is the demand for product C that we expect for the upcoming period. So these constraints here, they model expected market demand and the fact that we cannot exceed expected market demand for the various products. And now we still need to add one last constraint, which is the machine capacity. So I will write another function here, t1 x1 plus t2 x2 plus t3 x3, and this cannot be larger than capacity of our machine. So C is the machine capacity of our single machine, in this case 1200 minutes. T1, T2, T3, those are the processing times for product type A, product type B, and product type C. So again, down here, these are the decision variables. Those are the ones that we can change in our optimization problem. The solver can adjust the values of the decision variables in order to find an optimal solution. He will try to find an optimal solution by maximizing the objective function while satisfying the constraints, and T1, T2, T3, P1, P2, P3, and the constraint values, these are all input information. This is known information that we put into a model, and the solver will not adjust these values. These are parameters of a model. And now we will implement this mathematical model in Excel and solve it with Excel Solver. This I will go to the Data and Model tab in the Excel file that I also added to this course. You can find it in the Resource section. And you can see I like to divide this tab into an Input Data section, a Decision Variables section, an Objective Functions section, and a Constraint Functions section. The input data section lists all of the input data that we know and that is relevant to a problem. In this case, the coefficients and constraint values that I consider in my mathematical model. So if I take my mathematical model again, P1, P2, P3, the profit margins of the various product types. Those are the coefficients that are listed here. This is known information that the solver will get access to in order to find the optimal solution. T1, T2, T3, the processing times of the various product types on the machine. You can find them here in column F. And then the constraint values D1, D2, D3, the expected market demand for the various product types. You can find that I listed them here in column E. And down here you can find that I added one last known parameter that we are aware of, and that is the machine capacity, so parameter C. There's not really a limitation to how you need to set up your parameter cells. You can do it in whatever way you think is best and whatever makes most sense to you. And in this case, I just chose to display it like this, but you could add the parameter values in whatever way you would like to. The important thing is that the solver has access to cells that contain the relevant input data. So you need to put this information somewhere in your Excel file. Next, the solver will need to know some cells that can be manipulated in terms of value, and these would be the decision variables, the values that the solver will adjust throughout the optimization run in order to find an optimal solution. So we need to find some cells that are used for modeling decision variables, and in this case those are the cells that I highlighted in blue here. Again, you can put these cells wherever you want. The important thing is that the solver knows the cells that contain the decision variables. Another thing that we need to provide to the solver is the objective function itself. We will tell the solver inside the solver settings whether the problem should be maximized or minimized, but we need to provide a cell that contains a function for calculating the objective function. So we need to model the objective function in a cell. Again, you can put this cell wherever you want. I highlighted it here in green, and you can see that this cell contains the formula for the profit margin. So if you see here, I summed up the profit margins by product type with the quantity produced by each product type. In sum, that is the total operational profit or total aggregate profit margin that our production program will generate. And this is the value that we want to maximize. And one last thing now that we need to provide to the solver in terms of cell values in a sheet are the constraint functions and the constraint values. So in this case, I put the cells here. Each cell here contains a function for calculating the relevant constraint function. So one function is the total processing time required for a production program. If you see here, this is the sum of the processing times with the respective product type. In the mathematical model, this would be T1 x1 plus T2 x2 plus T3 x3. This is the function, this function here, the function that I put into this cell. Now for documentation purposes, I also added here the direction of the constraint so that this value here calculated by the function has to be smaller than the machine capacity, 1200 minutes. And I also put here again the machine capacity. But the solver doesn't require this since we already have the information available up here. So this is just something I did for documentation purposes and to make it more easy to understand what is being modeled here if you share this file with someone else. But it's definitely not something that you need to do, and we could provide the solver with the cell values up here instead of listing them down here again. So this is just for communication purposes. So the other constraints were the expected customer demand, and these functions are easy since these are just the total amount of product produced by the various product types, so the decision variable values themselves. So demand for product A, the actual amount produced, would be, if you look here, D15. This cannot be larger than the expected customer demand, which we have up here. And the same for product B and product C. So up here, the known data that we have. Here, the cells that the solver can manipulate in order to find the optimal solution. Here, the function that the solver will maximize, or if you have another type of problem, minimize in order to find an optimal solution. And down here, the constraint functions for calculating the constraints and to provide the Excel solver with the information of whether a constraint has been violated or not. So the solver, in the solver model itself, which I will explain now, we will add the constraints themselves. So the solver will check the function values of the constraint cells against the constraint values and make sure that the solution is feasible. So the last thing we need to do is, in the data tab of Excel, we will click on our Excel solver tab or Excel solver add-in, and this model instruction tab will appear. And here we have to set up our mathematical model. So this is the actual implementation of the mathematical model. So let's go through that now. We'll put here the mathematical model formula. We'll put the solver implementation on the other side. So the first thing is we need to provide the solver with a reference to the objective function. You can see here I can choose whether I want to maximize or minimize the objective function. And I need to provide a reference to the objective function itself. The objective function is what we modeled here, the sum of all the profit margins with the quantity produced of each product type. Once we did that, we need to provide the solver with a reference to the cells that contain the decision variables, so the values that the solver is allowed to adjust. And those were the cells that are listed here in blue. We also need to add some additional constraints, which I don't have to model here in terms of cells, and I don't need to provide any cell references for this. But if you look in my model, you can see that x1, x2, x3 are integer values. So they can only take the values 1, 2, 3, 4, and so on. No continuous values. And this I have to add as a constraint under the constraint section. So I will add constraint, and then I can choose whether the whether the respective cell is an integer cell, or whether it is a continuous cell or a binary cell. I can add these constraints, so in this case I have to add constraints that all of the decision variables modeled in the blue cells here are integer variables. And here I now actually opened the Excel solver add-in to show you how you can add the constraint that a decision variable has to be integer. We set up the objective function, the objective of maximizing it, the decision variables, and now we want to add to our model that cell D17 for modeling the decision variable of how much of product C we want to produce has to be an integer variable. For this I need to click on add. And then I have to provide a cell reference. So in this case, the decision variable for how much we want to produce of product C is modeled in cell D17. And then here, usually I can put a constraint value here and I can choose the direction of the constraints. But you can see I can also add a constraint type that says int. And now this makes sure that cell D17 can only have integer values. So I click add and then cancel, and then you can see I now successfully added the constraint that cell D17 has to be an integer value. all of the other constraints are already set up here. So the constraints would be the functions that I modeled down here, and then I have to provide the constraint value. But also this we can do together. So let us, for example, set up the constraint that the machine capacity may not exceed the required, the utilized machine capacity may not exceed the production capacity of the machine. So I will delete this constraint, and now I will add it. So for this I have to reference the cell that contains the constraint function. This was the cell here. And I need to provide the direction of the constraint, and we want the value of the constraint function to be smaller than the machine capacity or equal to the machine capacity. And lastly, I need to provide a reference to the value of the respective constraint. So the cell that contains the constraint value, I could choose the cell down here or the cell up here. So let us, for example, choose the cell up here that contains the machine capacity. Then I click OK, and now I can click OK here or add, whatever you want. If you click add, you can add additional constraints, and if you click OK, it will add the constraint and then exit this terminal. So I click OK, and you can see this constraint is now listed here. The constraint function for modeling the required machine capacity has to be smaller than or equal to the value in cell C10, which contains the machine capacity. In the same way, if I want to change this, I can click on change, and instead of referencing cell C10, I could reference cell E26, which contains the same value. So let me click OK here. So now you can see, instead of referencing the constraint value from cell C10, I'm now referencing the constraint value from cell E26. In this case, it doesn't make any difference. But if you want to make changes to your solver model, you can select the respective constraint and click change, or you can also delete constraints by clicking on delete. And now we're basically done with setting up our model. We implemented our mathematical model that we defined here into Excel, and we're now using Excel Solver to solve this problem. And for solving, we can choose different solution methods, and there are 3 different options that are available here. And since we are solving a linear optimization problem, we can click on simplex for linear programming. And then I just have to click solve. And then there will be a pop-up informing you about the solver results. And you can say, in this case, the solver found an integer solution within tolerance and all constraints are satisfied. And I can now choose whether I want to keep the solver solution in my cells, or whether I want to restore the original cell values. In this case, I want to keep the solver solution, so I select keep solver solution, and then I click OK. And now you can see here that what has changed are the values of these cells here. And those were the cells that we told the solver that the solver is allowed to change the values inside them. And based on these decision variable values, we can see the total operational profit. This is what we wanted to optimize. And down here, we can see the constraint function values, and we can compare it to the constraints. So we can see here that we produce as much as we could from product C, and then we also produce as much as we could from product B, And then basically whatever capacity we had left, we used to produce product A. And the total machine capacity that we are utilizing is 1,198 minutes compared to the 1,200 minutes that were available. And that is because product A has a processing time of 3 minutes. So if we produce one more product of product A, we will end up not satisfying the machine capacity constraint. Now, if we want to make a sensitivity analysis, we can, for example, manually enter the decision variable cells, and we can test this solution a little bit. So right now we have a value of 1,532. All constraints are satisfied down here. So let us, for example, reduce this a little bit. Let's put 60 here. The operational profit would go down. The machine capacity is still satisfied, of course. And the demand constraints of product B and C are, of course, still satisfied. I could now try to use this machine capacity that is still free for some other product, for example, product B. If I have 20 minutes available, I can produce 5 additional units of product B. So let us try to add 5 more units to the production program of product B. Our operational profit would, of course, increase, but if we look down here at the constraints, the calculated constraint value for the demand of product B would be 55, which is larger than the expected demand. So in this case, this constraint would not be satisfied, and that is why the solver didn't allow that many units of product B to be produced. So I think this was the introduction of Excel Solver for a simple linear optimization problem, and I would recommend that you download the Excel file that I attached to this course in the resource section, and that you try to open the Solver tab and adjust the model a little bit, maybe delete all of the constraints and set them up again, and try to solve the problem so that you get an understanding of how to use Excel Solver for solving optimization problems in Excel.